welcome to this paper Snapshot series. I'd like to start with my personal motivation for each work. So in this case, I was working as an application engineer back in São Paulo, Brazil, at Voight Hydro. And it was 2018. We started seeing cybersecurity requirements in our customers' technical specifications. And it was somehow a new topic. I didn't know what to propose for those requirements, and that's why I decided to focus on this for the thesis of the MBA that I was attending. So it's also important to mention that I was guided by Ricardo Galvão, which is a great professional. He was also in the energy sector. It was invaluable help to develop this work. So now we are moving to the highlights of the paper. As I said, it's from the assets owner's perspective, and the standards that I chose for this study was IC 63443 due to its relevance. And then from the perspective of asset owners, they had to first initiate the cybersecurity management system in their power plants. And actually, in the standards, it's composed of 6 main steps. So, of course, you first decide to initiate the program, and then you perform a high-level risk assessment, detailed risk assessment, and then establish policies, procedures, and awareness programs, implement the countermeasures, and keep maintaining this. So it's a continuous process. It doesn't need to be a direct path between these steps. But as I said, it's continuous, and the first step being a high-level risk assessment is actually to define the priorities, what are the main threats you want to defend against, and your risk tolerance. So only after you decide this kind of, let's say, business goals, you move for the detailed risk assessment. And then for the detailed risk assessment, we followed an approach that I had seen in a magazine about industrial automation, which was transforming a HAZOP, safe risk analysis, into a cyber HAZOP. So for each scenario, each system, it was possible to evaluate if it was hackable or not, what were the existing countermeasures, and if they were not sufficient to make it inherently safe, then you would decide what additional measure would be implemented to be safe in terms of cybersecurity threats. So we applied this approach for a case study of a power plant for which we really had a HAZOP, and by that time we involved other teams at Voight Hydro. They supported into evaluating this to see what were the existing countermeasures. So it was a really interesting work. Not everyone participated in writing the paper, but I will never forget this support that I had from the engineering teams who helped me to evaluate the existing HAZOP and transform it into a cyber HAZOP. And I would say that one of the main results is that after this evaluation, we saw for the main systems what were the most commonly hackable scenarios, and also how the risk tolerance could influence the architecture zoning in the end. So if you have a higher risk tolerance, it might be that you have less zones in your automation architecture. And of course, if the risk tolerance is very low, then you did more security measures, more firewalls, which means also that you have more zones into this architecture. And we exemplify it in the paper, suggesting architectures for low, medium, and high risk tolerance. And this is, I guess this is one of the key contributions of the paper, because we show that from the high-level risk assessment, it influences the detailed risk assessments, the measurements, and also how we define the zones and security cells of the automation architecture.